Hello everyone, welcome to the course Data Structures. This is Thulasi Chitra, Associate Professor, Department of CSIT, MLR Institute of Technology. And in today's session, we will be looking into the red-black trees concept. Under this, we will be discussing about what is red-black tree introduction. Then we are going to perform red-black tree insertion also. If you have given some elements, based on that, how to construct a red-black tree. What is red-black tree? Red-black tree is another variant of binary search tree in which every node is colored either red or black. You may have a node with red color or a node with black color also. Right? We define those type of trees or nothing but the red-black tree. And red-black tree in short, we can define it as red-black tree is a binary search tree in which every node is colored either red or black, as we have seen in the previous definition. And here, every red-black tree is a binary search tree, right? Every red-black tree, what you are going to construct is a binary search tree. And every binary search tree need not to be a red-black tree, right? Red-black tree, what you are constructing, that is a binary search tree. But whatever the binary search tree you are going to construct, that will not be a red-black tree. Please remember this. It is not vice versa, right? And when I want to have a red-black tree to be constructed, in that we need to follow the following properties. What are the properties we need to follow? First, the property 1. Red-black tree must be a binary search tree. Yes, it has to follow the BST properties. As the root node, compared with the root node, left part of subtree will be having all the lesser elements. On right subtree, you have the all greater elements. The root node must be colored black. Always the root node must be in the black color. The children of red colored node must be colored black. The children of red colored node must be colored black. That is nothing but there should not be any two consecutive red nodes. I should not have any two consecutive red nodes that should present. Right? So that we are going to make the child, if it is having the red color, one node is having the red color, the other should be in the black color. Okay? Next, other property. In all the paths of the tree, there should be the same number of black colored nodes. If I am going to check the path of a tree, like this, the path, all the paths, if I am going to check, right? In all the paths, you are going to have the same number of black colored nodes that will present. Okay. Next, every new node must be inserted with red color. When I am going to insert a new node, that should be always in red color. And every leaf node, that is null node, must be colored with black. Okay. For you to understand all these properties, let us see one example. What is the first property you have? The red-black tree must be a binary search tree. If you can check with the root node, on the left hand side, all the elements are lesser than 11. On the right hand side, all the elements are greater than 11. Next, what is the second one? The root node must be always colored black. Yes, here the root node is always coloring black. Here, the child of every node. If you could observe, for red, I don't have any red color child node. For red, I don't have any red color child node, right? If everywhere you are going to check. If I am going to have that relates to a conflict, we need to change that color, right? Then, in all the parts of the tree, there should be same number of black colored nodes. This is one path, right? This is another path. And here you have another path. In each and every path, if you could observe, for this path, 11 and 1 are two black colored nodes. And in this path, you have 11 and 7 is another same black color nodes. And in this path, I am going to have all black color nodes, all two black color nodes in every path, right? Then you have one more. All child nodes must be with null color. These are the child nodes. All null nodes will be filled with black color, right? And a new node which is going to be inserted always will be in the red color. This one, when you are going to perform the construction of a red black tree, there we will be seeing that how we are going to insert a new node. Now, when you are going to perform the insertion, let us see what are the steps to be followed. In red black tree, every node must be inserted with the color red. The insertion operation in red black tree is always similar to the insertion of operation in BST, this binary search tree, but it is inserted with a color property. As we have done with the BST, the same procedure we are going to follow here, but only the coloring property is going to be different. And after every insertion operation, we need to check all the properties of red black tree, right? After every insertion, we need to check whether it is satisfying the property of red black tree or not, right? If all the properties are satisfied, then we go to the next operation. What are the operations that we are going to perform is going to be performed. Otherwise, we will perform the following operations to make it red black. If the particular conditions are not satisfied after performing insertion, then we will go with the other operations to be performed. What are those operations we will perform here? One is we are going to recolor it. The other one is we are going to perform the rotation. And sometimes we need to perform both the things, rotation followed by the recolor. Right? These are the three things that has to be done if we are going to perform the insertion. After insertion, if it is not satisfying the properties of red black. And this is the algorithm we can consider. By using this algorithm, we are going to construct or insert elements to have a red black tree. The insertion operation in red black tree is performed using the following steps. First, check whether the tree is empty. Yes, if the tree is empty, then what we are going to do? Then insert the new node as a root node with the color black and exit from the operation, right? If I am going to have the tree is empty, then I am going to create a new node and that becomes the root node, and that root node should be always in black color, right? If it is done, then we are going to come out of that operation. If the tree is not empty, then insert the new node as a leaf node with color red. If already I am having a root node, then I need to insert a new node with the color red. That means always a new node will be inserted with the red color, and that becomes the leaf node. And if the parent of the new node is black, then exit from the operation. If you don't have any conflict, then directly what you are going to do, parent of new node is black, then directly we will be exiting from the operation. And we have some other case. These are the main three cases where you need to check mainly. If the parent of the new node is red, that means if you have any conflict with the red color, two consecutive nodes are in red color, then check the color of the parent node sibling of the new node. Then we are going to check with the parent node siblings, and based on that what we need to do. If the color is red, parent node sibling is red, then parent's parent is root node. Parent node sibling is red and parent is root node. Just we use recolor to make it red to black, right? Here with this example we will understand what is happening here, right? If the color is red, the same parent node sibling is red and the parent's parent is not root node. If it is not root node one condition, and root node not having root node also another condition. Is not root node, we recolor and recheck. After recoloring, we are going to recheck it. If it is a root node, just if it is of in red color, we are going to make it black. That's all. If the color, that is parent node sibling, is in black color or null, then what we are going to do? Do suitable rotations and recoloring. We need to do the recoloring at the same time. We need to perform the rotation also. If it is colored black or null, then make suitable rotations and recoloring. The same process we are going to repeat. After recoloring and rotations has been done, still there is any conflict, again we are going to perform the rotation and recolor it. As this is the example, with all the elements we are going to check for all the cases here, right? Create a red black tree by inserting the following sequence or sequence number. This is the element These are the elements that was given. First, I want to insert 8. What is the first step in the algorithm? First, we need to check with the tree is empty or not. Yes, tree is empty. So, we need to insert the root node with the black color. Yes, I have inserted it with black color. That is the root node. Because of that, we are going to insert with the black color. Next. Now, I want to insert 18. 18 is greater than 8. Follow the BST property also. But here the tree is not empty. Now, what I need to do? I need to insert that node as the leaf node with color red. If I want to insert a new node, that should be always in the red color. If it is of root node, it will be in black color. Now, insert 5. 5 is less than 8. Where I need to insert it on the left of it. So, here I am going to insert a new node. So, it should be on the in the red color. Next, insert 15. Now, tree is not empty. You know this. So, insert a new node with red color. Where I need to insert 15. Check with 8 first. It is greater. Check with 18. It is lesser. So, I need to insert 15. But the new inserted node should be always in the red color. Yes, insert. Now, after inserting, there is a conflict. Now, observe the statements. The same algorithm what we have done. There are two consecutive red nodes, 18 and 15. Now, what we need to do? We need to check with the new node parent sibling color is red. New node, this is the parent sibling is red. Right? That is one condition. And at the same time, we need to check for another case. Parent is root node. Yes. Parent is root node. So, what we are going to do? Just we are going to recolor to make it red and black. Right? Just we are going to recolor it. Which of them has to be recolored? These two has to be recolored. These two are going to be recolored. Why? Because we are not going to recolor the root node. Root node will be the same. Right? Which are in red color, those will be recolored. Right? Because of that, you are going to get these two on as the black nodes. Next, insert 17. Now, I am going to insert 17. Always new node should be inserted with the red color. 17 is greater than 8. Move to the right side. 17 is lesser than 18. Move to the left. 17 is greater than 15. So, I am going to insert here. Again, I am going to get the conflict. I am having the conflict. 15 and 17 are conflicted. Now, check with the new node parent sibling. Here, this is the new node, this is the new node, this is the parent. Parent sibling is null. Right? Parent sibling is null. So, we need to perform the rotation. When I am going to have the parent sibling is black or null, perform the rotation and we are going to recolor it or recheck it. If I am going to do this rotation, what is the rotation here we need to do? This is because of LR, it is right, LR. That means we need to perform the rotation, LR rotation we need to do. When I am going to do the rotation here, we need to get the elements like this. 15, 17, 18, 17 is the middle element. So, 17 becomes the root node and 15 and 18 becomes the left and right child of it. When I am going to do this rotation, observe 17 is in red color and 15 is in red color and 18 is in black color. Right? Now, we need to recolor it. Which of the colors we need to change? Here, recolor according to this. Here, already 15 is in red color, right? 15 is in red color. We need to recolor this one to red and 17 already in red color. That should be converted to black. Right? Like this way, we need to convert. As a simple example, I can say whatever the child node color, that will be getting the same color to the sibling also. and the root color has to be changed to the other one. Why? Because you should not have the conflict, right? Like this way we are going to perform the rotation as well as the recoloring. And insert 25. Here also we are going to insert the new node 25 in the red color. Is after inserting you have the conflict. Now check for the new node parent sibling. New node parent sibling is in red color, but its parent node is not root node. Now what we need to do? We need to recolor and recheck. We need to recolor and we need to recheck. Just recolor them. These three has to be recolored. 15, 18 are going to be recolored and 17 is black color, so that we need to make it as a red color. After doing this, check is there any conflict? No conflict. Next go for the next insertion. Now insert 40. There is no tree is not empty. Insert 40. 40 will be inserted after 25. So that I am going to have the conflict here. Now check with the new node parent sibling. New node parent sibling is null, right? This is null. Because of that, we need to perform rotation as well as recoloring, right? Perform rotation on these three. When I am going to rotate all these three, I am going to get 18, 25, 40. 25 is the middle element and 18 and 40 are the left and right shields, right? Now recolor all of them. Now 18 becomes the left shield and 40 becomes the right shield, and right shield you have already 40, right? Except 40, which is the new node that has been inserted, remaining 2 has to be recolored. Please remember that, right? 18 is coloring red and 25 is going to color it as black, right? Is after changing this, once check it, is there any conflict? No conflict. So moving on to the next one. Now I want to insert 80. I want to insert 80. Here tree is not empty. Where I need to insert 80? Right of it. Right of 40 I need to insert. Again I have the conflict, right? Because of this conflict, what I need to check? Parent sibling I need to check. After checking parent sibling, it is in red color. Because of red color, we need to perform recoloring, right? Recolor and recheck. I need to recolor these nodes and I need to recheck it. These two nodes become black and this becomes red. These two becomes black, recoloring, right? This becomes red. Yes, after doing that, this is the one which you are going to get. Now if you are going to recheck it, here I am going to get the conflict, right? This is the new node we need to consider now. This is the conflict where you are going to get occurred. Now again check with this. This will be considered as the new node parent sibling. Parent sibling is in black color, but parent is root node. So what we need to do? Just we are going to perform the recolor, right? Here parent sibling is black, so we need to perform the rotation. So we use left right rotation and then we are going to do this one. Now because of this black color, now we need to perform the rotation on this. What is the rotation we are going to do? We are going to perform rotation on these three nodes. These three nodes will be rotated. That is 17 becomes the root node, 8 becomes the left shield and 25 becomes the right shield. After rotation, after rotating these three nodes, what you are going to get? 17, 8 and 25. These are the main nodes which you have been rotated. Now already this is in black color, 17 is in red color and 25 is in red color, right? Now don't consider the new node which you have taken, right? The remaining nodes has to be recolored. Now this should become the red color and this should become the black color. Okay, done. Now after doing this, now place the remaining elements. 17 left is 15, but we don't have place for 15 here, so that we need to place it as the right of 8, and 25 left is 18, same as it is we can place, right? And then we have 40 and 80, you don't have any conflict. So this is a perfect red black tree that has been constructed. We can check what are the other properties. On every path we need to have same number of black color nodes also. And while doing while solving any example, you can check with this algorithm and you can able to construct a red black tree. And the overall summary of this concept is the red black tree introduction we have seen, and we have seen how to construct a red black tree for a given elements, and we have solved an example also, so you can try that same example, and you can take few more elements, try with the other example also. But you have to follow the BST property while constructing the red black tree, BST property, and we need to follow the properties of red black tree also, right? Everything has to be satisfied to construct our red black tree. I hope you understand this concept. Thank you.